You find yourself floating in the middle of nowhere. There are no stars near you, no planets, no light, and then you see it. A black hole, a cosmic monster silently pulling everything around it, including you. What would happen if you fell inside? We're about to find out. But first, how do you get so close to a black hole without getting destroyed? Well, it's actually possible. Just don't go near the event horizon. That's the region around the black hole where space and time become distorted beyond repair. As long as you stay outside of it, you should be fine. Okay, so here you are on the edge of the event horizon, the last place where rescue is possible. You may think that you could just turn around and fly away from there. And indeed, according to Einstein's theory of relativity, you could. In theory, you would need to accelerate to an insane speed close to the speed of light and make a U-turn around the black hole. But then something interesting happens. The more mass a black hole has, the larger its event horizon. So the faster you have to move to escape. In other words, you need to get very close to the edge of the black hole before you start accelerating. Otherwise, you won't have enough time to escape. At this point, you may choose to ignore the problem and keep floating towards the black hole. Let's see what would happen next. Now, you cross the point of no return. Space and time have become so distorted that nothing can escape from here, not even light. So any hope of rescue is gone. But you're still alive. For now, at least until you hit the singularity. Here things get tricky. According to physics, the singularity lies at the center of every black hole. It's an infinitely dense point with gravity so strong that it pulls everything into it. But the problem is, we don't really know what happens next. That's because the laws of physics as we know them break down at the singularity. They don't work anymore. One reason for this is that our equations assume space is infinitely big. But near a black hole, space is not infinitely big. It's finite. That means that the equations we use to describe the universe don't apply anymore. So we don't know what happens when you cross the event horizon. Does the singularity destroy you completely? Does it send you back in time? Does it teleport you to another universe? Or maybe you experience total darkness and nothingness. The only thing we know for sure is that if you fall into a black hole, you won't be the same ever again. But what would you actually see while falling? Theoretically, you would see a lot of cool stuff. As you fall towards the black hole, you would notice that everything around you becomes distorted. Stars would appear to be squished into long, thin noodles. Then they would disappear behind the horizon and be gone forever. The sky would turn into a kaleidoscope of colors as light waves crash into each other. And finally, you would see the singularity itself, a bright white light that would eventually consume you completely. But you wouldn't be able to observe all of this for long. Eventually, the gravitational forces would be too strong and tear your body apart. The heat would be thousands of degrees, hot enough to burn your entire body in less than a second. At that point, you would be nothing but a pile of ashes. So, if you were to fall into a black hole, you wouldn't last very long. But it might be a quick death compared to what awaits you at the singularity. Once you cross the horizon, you enter a region of space where the rules of physics no longer apply. Here, time stops. The singularity lies ahead, shrouded in mystery. What secrets does it hold? Perhaps we will never know. Now that you've learned what a black hole is, how they form, and what would happen if you fell in one, tell us in the comments which facts surprised you the most. Do you think you could survive a trip inside a black hole? Maybe. If you like this video, give it a thumbs up and don't forget to subscribe for more updates on all things space. Black holes are fascinating and mysterious objects that continue to captivate astronomers and the public alike. If you want to learn more about them, check out this playlist. Thanks for watching, and see you next time. You find yourself falling towards a massive black hole. Your spacecraft is plummeting through the void. Okay, now our spacecraft is getting closer. At first, it doesn't seem too bad. But then, strange things begin to happen. The starlight around us bends and distorts. This is gravitational lensing. Space itself is being twisted. If you looked back at the galaxy behind you, You'd see it stretch and curve into bizarre shapes like a cosmic mirror that's broken. The closer you get, the stranger the view becomes. The black hole, S accretion disk, a glowing ring of superheated gas, swirls around you like fire trapped in an infinite circle. It's beautiful and horrifying at the same time. You feel the intense heat on your face as the black hole's gravity tears at your spaceship. But there's no air to burn or choke on. You struggle to keep control of the craft as it speeds towards the event horizon, the boundary between infinite space and eternal darkness. Just a little further, and the stars in the sky begin to shift and distort until they form long, thin streaks. The ship shudders violently. You don't have to look back to know that the familiar constellations have been replaced by a swirling vortex of distorted light and matter. You are close to the edge of the black hole's event horizon. But the most terrifying part is not what you see, but what you don't. For out of the corner of your eye you spot another ship, one that had been following you. You hoped it would stop at a safe distance. But now you see it's just as close as you are, almost touching. Its crew must have realized there was no escaping this trap together. Did they decide to stay, or were they trying to warn you? And then you pass the horizon. From far away, if someone were watching you fall, they would see you slow down. It would be as if time itself froze for you at the horizon. They would never actually see you cross. But for you, sitting here in your spaceship, time feels perfectly normal. You'd pass the horizon without noticing any clear dividing line, but the moment it happens, escape becomes impossible. No rocket engines, not even the speed of light can help you now. You are inside. The interior of a black hole is smooth, featureless, and dark. There's nothing to see except an endless expanse of nothingness all around you. Without any reference points, you won't know which way is up or down. There's no sound, no sensation, only the feeling of utter stillness. As you drift along, you might come across something unexpected, a vast, empty space in the darkness. A doorway, perhaps, or maybe the entrance to a cave. You could try going through it, but whatever lies on the other side is unknown, perhaps dangerous. Are you brave enough to find out? Or would you rather turn back and go the other way? But of course, there is no other way. There is only the way forward. You move deeper into the black hole. The darkness is absolute. Your spaceship is falling faster and faster. It seems like an eternity, but it's only a few minutes. Suddenly, the darkness parts. Ahead, you see a brilliant white light, the end of the tunnel. Just beyond it, you can make out the faint outline of a colossal structure. You've reached the center of the black hole. The black hole is a place of unimaginable power, where space and time are twisted and distorted beyond our understanding. What happens next is anyone's guess. The white light is blinding. You shield your eyes, but it's too late. You've been met with the ultimate cosmic horror. The singularity. All around you, space is torn apart. In this maelstrom of infinite energy, everything is destroyed, devoured by the black hole's insatiable appetite. Even light cannot escape its clutches. You're being pulled towards the heart of the storm. You struggle to hold on, but it's no use. You're being ripped apart, atom by atom, and scattered to the winds. Then there is nothing. You have reached the end of the journey, the final frontier. Black holes are arguably the scariest objects in the universe. Not only do they destroy everything that gets too close, they also warp the very fabric of space-time. We can observe how matter behaves around them. We can watch light bend and distort as it escapes their grasp. But there's one thing we can't quite wrap our heads around. What really happens inside a black hole? For the sake of your sanity, let's start with the zone immediately outside. If you were free falling toward the center of a black hole, your first warning sign would come long before you ever saw the event horizon. As you approach the singularity, gravity near a black hole is not just strong. It's uneven. Your feet, being closer, are pulled much harder than your head. The result? Your body begins to stretch vertically, while being squeezed sideways. Scientists actually gave this nightmare a funny name: spaghettification. Yes, you would be stretched out like a piece of spaghetti, thinner and thinner, until your very atoms are ripped apart. It sounds almost silly, but in reality, it's one of the craziest and most violent forces in the universe. And to understand how it works, all you need is some basic physics and a little imagination. Let's assume our brave astronaut isn't squeezed to death by a supermassive black hole, but instead slowly approaches a relatively small one around 20 times the mass of our Sun. Our astronaut starts from 300,000 kilometers away, which is 3 times the radius of the black hole. At this distance, the gravitational force would be about 8,000 GS. If she decided to take a deep breath, her lungs would explode. So it would be hard to breathe, but at least she wouldn't be crushed or torn apart. She'd have plenty of time to change her mind and turn around. She'd have 10 seconds for that because the rocket needs time to accelerate after the burnout of the engines. And the escape speed from a black hole is higher than the speed of light, so there's no chance she'll make it without a lot of preparation. But 10 seconds is enough to reconsider. When the astronaut is 100 times the radius of the black hole, the gravity will be thousands of GS. Her blood would boil, and that's assuming she's not already dead from the lack of oxygen. But she still has time to react. If the rocket accelerates in exactly the opposite direction of the fall, she has 6 minutes to get out. The moment she crosses the Roche limit, the tidal force will start tearing her spaceship apart. Actually, there's no need to tear the ship apart. Its destruction starts long before it reaches the Roche limit. When the ship reaches the last stable orbit around the black hole, the tidal force is strong enough to pull the satellite right out of orbit. Now the astronaut finds herself falling freely towards the singularity. She has less than a minute to prepare for the worst, because now the acceleration due to gravity is hundreds of thousands of GS. The astronaut is no longer a human being. She's nothing more than a pile of human-shaped pancakes, if she was ever human to begin with. No spacesuit will withstand this pressure. It will tear, and the poor astronaut will be subjected to the most terrible torture known to physics. Spaghettification. Imagine your legs were pulled by several billion newtons of force while your upper body remains practically motionless. You won't survive for more than a few seconds under such tension. Your muscles, bones, and tendons will stretch beyond their limits and tear. Blood vessels and internal organs will burst and mix with each other and with the outer skin. By the time the astronaut reaches the event horizon, she becomes unrecognizable. She turns into a distorted jelly-like blob, a broken necklace of human flesh. If the astronaut managed to survive, which is impossible, she wouldn't for long. In the next few tens of meters, the gravitational force will increase to millions of GS. Even the strongest materials will rip apart under such pressure. The poor woman won't even have time to scream. She'll be completely crushed and turned into a pancake batter. At best, she'll be slightly flattened, but that'll be only the beginning of her torment. Now the astronaut is inside the black hole. From the moment she crossed the event horizon, the laws of physics stopped working. No signal can get out of the black hole, so we can't directly see what happens to the astronaut. All we can do is make predictions based on Einstein's equations, which are no longer valid past the event horizon. According to Einstein's theory, the gravitational force near a black hole tends to infinity as you approach the singularity. Thus, the astronaut experiences infinite gravity. She's infinitely far from the horizon and infinitely close to the singularity. So, the acceleration due to gravity increases to infinity. The same happens to time. According to Einstein's theory, the closer you get to a black hole, the slower time passes. Near the event horizon, time stops altogether. From the perspective of the observer outside the black hole, the astronaut seems to freeze in her fall. At the same time, the gravitational field of the black hole approaches zero, which means the astronaut essentially experiences weightlessness. These two phenomena, infinite gravity and zero gravity, seem paradoxical. However, they can coexist because they can never be observed at the same place. Either you're inside the black hole or outside. You can't measure both effects at once. For the astronaut, it looks like she froze in time. But in reality, time flows normally. Every second she experiences is equal to billions of seconds outside the black hole. The astronaut will keep falling until she reaches the singularity, a region of infinite density. Everything around her will be compressed to an infinitesimal size. Our physical laws break down at the singularity. Matter ceases to exist. Elements decompose into elementary particles. Elementary particles split into quarks and leptons. Leptons split into fractions of a second. Even the concept of time loses its meaning. There's nothing left. The singularity is a void, nothingness, an end to the universe. Or maybe it's a new beginning, a gateway to another universe. This is what physicists argue about, because the singularity doesn't exist in the present. It did exist in the past, 13 billion years ago. This is when the universe began. And it will exist in the future when the universe ends. But right now, the singularity is nowhere to be found. It's non-observable. It's not in any galaxy, not even in the center of our Milky Way. There's no singularity anywhere. But what happens to the astronaut inside the black hole? Does she reach the singularity or does she disappear without a trace? Modern physics assumes that nothing can escape a black hole, not even light. Once the photon crosses the event horizon, it falls to the singularity and disappears forever. So, what happens to the astronaut? Does she die? A few decades ago, scientists thought she would cease to exist, but that idea was abandoned. According to modern ideas, the astronaut reaches the singularity, but she can't cross it. The singularity repels everything and doesn't let anything through. It's like a wall, an insurmountable barrier. It's possible that the astronaut is trapped in the singularity, doomed to an eternity of torment. Or maybe the laws of physics are different inside the black hole and the astronaut disappears along with the singularity. Perhaps she becomes part of another universe. No one can tell for sure. There are many theories, but none of them can explain what exactly happens to the astronaut inside the black hole. In fact, we know even less about what happens inside a black hole than about what's outside. We can't directly observe either, but at least we can track changes in the gravitational field and look at the radiation coming from the accretion disk. And while we don't know what happens inside a black hole, we can say for sure that it has a profound effect on time. As you fall further, relativity shows its power. Time itself doesn't behave the way you expect. To you, every second feels normal. But if you could somehow watch the universe outside, you'd see it race ahead. Stars, galaxies, even the entire lifetime of the universe might appear to flash before your eyes. Time slows near you, while the rest of the cosmos speeds up. Black holes don't just swallow matter, they twist and stretch time itself. Now imagine that you survived the fall. After the accident, you find yourself on a strange planet similar to Earth. It's the same air, sky, and gravity. However, the main difference lies in the fact that time on this planet passes much faster than on Earth. Soon, you'll be an old man while your friends and family remain young adults. They'll age noticeably slower. Meanwhile, you can live your entire life over and over again, millions of times. What if this planet actually exists somewhere in the universe? Is it real, or is it inside a black hole? Let us know in the comments. What if I told you that black holes are cosmic paradox machines? That they destroy our classical understanding of physics, yet they may hold the key to unifying relativity with quantum mechanics. Do they erase information forever? Or do they open doors to new dimensions? For now, we simply don't know, and that's what makes them both terrifying and irresistible. Here's what we do know. A black hole is an inescapable region in space-time. Once you cross the event horizon, there's no coming back. Not even light can escape its grasp. So if you were to fall into a black hole, you wouldn't just be met with an intense gravitational pull. You'd be stretched, frozen, spaghettified into a thin noodle by the immense forces involved. And ultimately, you'd disappear into a place where the rules of physics as we understand them simply stop making sense. But black holes aren't just cosmic monsters. They're clues to the deepest mysteries of the universe. Here's another fascinating fact. Black holes warp space-time so much that they can bend light around them, creating a ring of fire around their horizon known as the photon ring. This ring acts like a magnifying glass, allowing us to see things around the black hole in greater detail. It's like having a cosmic magnifying glass, allowing us to peer into the heart of darkness. But what if we could do more than just observe these enigmatic objects? What if we could use them to unlock the secrets of the universe? Some scientists believe that black holes could help us solve one of the biggest mysteries of our time, the incompatibility between Einstein's theory of general relativity and quantum mechanics. By studying black holes, we might be able to find a way to unify these two seemingly incompatible theories and create a new theory of everything. Others believe that black holes could hold the key to time travel. According to some models, the interior of a black hole is a wormhole that connects to another part of the universe, or even another universe entirely. By harnessing the power of a black hole, we might be able to create a portal to the past or the future. Of course, these are just theories. We don't really know what happens inside a black hole. But that's what makes them so fascinating. They represent the ultimate frontier of our knowledge, a place where we can test the limits of physics and our own imaginations. This has been your journey into the heart of darkness. If you enjoyed it, hit subscribe and join us here on HFYSPACE as we continue falling deeper into the cosmos, one mystery at a time.